my PPT is also visible, right?
Yes, it's visible. Yes.
Okay, good morning, everybody. I'm happy you have joined us today. So today we'll be understanding mushroom morphology, which is for identification of wild mushrooms. So first question is, what is a mushroom? So mushroom is a fungus, but we cannot say that all fungi are mushrooms. So there are a certain class of fungi which are ascomycetes and basidiomycetes, which will actually produce a fruit body. So, for example, like a tree, an apple tree will have its apple as its fruit. So the tree is the vegetative part, and the apple is the part which actually works as a reproductive organ. Similarly, mushrooms are the reproductive parts of the mycelium. So one of the main purposes of a mushroom is to produce spores. Like fruits will produce seeds, right? So for so that the role in the nature of their that particular species like continues. Similarly, mushrooms uh, will produce spores. So that is the one of the purposes of mushrooms in nature, right? So yeah, mushrooms are the fruiting bodies of the mycelium. So you can compare it like the entire tree is the mycelium, and the fruits like the apple fruit is the mushroom or the fruit body. So it's like how we see a fruit body, and we generally think about is it edible or not, right? That is the question which comes into our head when we think about the word fruit body also, or if we think about a mushroom. So we are an organism, which we are Homo sapiens. So hence we think about how we can utilize it. So before going into the details of morphology and finding out whether a mushroom is edible or not, or finding out if what is the identification and how can I look into a mushroom or how can I see a mushroom, I just want to address some belief system, because I understand that we are a big family and we have a lot of thoughts, and we this video will be reaching to a lot of people. With my experience in this field from the last 4 years or so since I have been foraging, uh, some people will say that it is a poisonous mushroom if it is red in color. Yeah, which is completely untrue. There is nothing like that. There are so many red, sparking red colored rasulas in the wild. Not all of them are edible, but a lot of them are edible. So there is nothing like a color can tell you about the mushroom being edible. Second thing is, like, it's growing on the ground and areas where a dog will piss, or something like if a dog pisses over there and a mushroom will come out. So there has been a lot of false beliefs regarding all this. So there are a lot of mushrooms which come out from the soil, which are very edible. In fact, they are replacement of meat in the Shravan Mahina, when when a lot of people who eat non-vegetarian food will stop eating non-vegetarian food, and they will use these mushrooms which are coming out of the soil as a delicacy. Yeah, it is high in protein, and it is said that a lot of pregnant women will also be eating them. So there are communities in India who have been eating mushrooms from a very long time. And if you go and tell them these things, they will just laugh at you. Third thing is that if it is white, it is edible. Again, so because we see the button mushroom in the market, it's not true that the button mushroom is white and hence it is edible. Colors cannot really tell you about the edibility of a mushroom. Yeah, and one of the most, this was a discussion which we had in the Myco-Asia group also, where someone said that all mushrooms cannot be touched directly. Well, that is not true. Till date, I have touched a lot of mushrooms with bare hands most of the time, because we are going deep into the forest sometimes, or any random place where we will not have gloves. I never even thought of wearing gloves for touching them. So just clearing some false beliefs before we start to see and understand how beautiful these organisms are and how can we look at them. So the question about edibility has been the most famous question in this space, because somewhat people relate IDing is one thing and then the next question is edibility. So addressing to that, So the edibility of a mushroom can be figured out after rightly identifying it. Okay, there is no straightforward way. This is the only way. There are edibility protocols that exist.
Can I
Yes, sir.
interrupt?
Yes, sir.
I want to ask from the audience, are the slides visible? Please say, please. Yeah, slides are visible. Please go ahead. Yeah, please.
So the edibility of a mushroom can be figured out only after identifying it. Okay. So there are edibility protocols that exist which experts will do, but I will not talk about it today because I don't want to be responsible for you going wrong in that protocol and doing something bad with your body. So the best and the easiest way is to get a positive ID. If you want to know about edibility protocols, we can take it up later on after the call, personally, not on the call. So the best and the easiest way is to get a positive ID. Identification means ID. And that can come on the field. So this is field specific. Okay. This entire presentation is what you can do on the field. Okay. And that can come on the field only if one knows how to observe and understand the mushroom morphology and then putting those pieces of the puzzle together to reach an identification. And this is what generally people like me also do. If I get a mushroom ID request, this is what I will do. I will look at its morphology. Now, what is morphology? Morphology, what is it? So, in simple terms, morphology is the study of the form and arrangement of the parts, right? So, for example, okay, before that, so today we will be completely focusing on morphology in this session. So, one very nice way to see it is the components of a mushroom which are visible to the unaided eye. So, when you don't need something like a magnifying glass or a microscope, so what are those things that you can see with naked eyes, or if you have specs, you wear specs and see, but basically without any other tool which magnifies the world for you. So let's get into it. So yeah, we are very much used to labeling diagrams ever since school. So let's understand this. This is how you label a mushroom, right? It has a pileus or a cap. So pileus is again an advanced word. So I will be using cap as a word for this presentation. Whenever I mean cap, it means this part of the mushroom, the top part, okay, which we generally see. Then there is certain decorations on the mushroom. It can be a universal veil or it can be some other sort of thing, which I will come into detail going ahead. Then the underside of the mushroom is the hymenium, which is also called the gills. So these are the spore bearing surfaces. So if you see a spore release video of mushrooms, you will see that the spores or the powdery substances coming out of the underside on that is from the gills. Then some mushrooms will have this partial veil. There is this stem of the mushroom, which is called the stipe. So stem is generally used for plants. When mushrooms, they use stipe. Some mushrooms have a sac-like structure at the bottom. There are multiple types of structures that can exist, and it's called the volva. And this thing is not labeled, but it is basically the threads of mycelium, which is connecting because it's the fruit body, right? So the mycelium has emerged as a fruit. So there are approximately 20,000 species of mushrooms, okay, according to the internet. Around 14,000 are labeled, they're named, and there are more to be discovered, is what they say. And not only mushrooms, but they say that only 10% of the fungi in this world has been discovered. So there is immense scope. So yeah, if you are a naturalist and if you find some mushroom, then it can be that it is not documented before. So yeah, let's understand how do we differentiate between them. So again, going just by the looks, the overall stature and the shape has also classified them into broad categories. These categories can be like these 10 categories that I mentioned: agaric, polypose, puffballs, coral mushrooms, jelly, jelly mushrooms. They look like jellies. Then there are boletails or the boletes. There are stink horns. There is crust fungi, and there is club shaped and other weird ones. I, we call it weird ones, like even Hari in the Indian toadstool. He We call it the weird ones because they cannot be classified. Like mushrooms like to break rules. We'll come to that. And there is cup fungi. Okay, so now I'll share some pictures about all of these. So the most common type of mushrooms that we see are these guild mushrooms, the agaric type. So agarics are the mushrooms which have a stipe like this. This was a mushroom. This is a mushroom called Leucocoprinus cretaceous, which I saw in Ahmedabad. I was very happy to see a mushroom which is growing in a hot environment like Ahmedabad, because that's where I'm from, basically. So it has a stipe, you can see. There is a partial veil over here where the pointer is. Then it has gills. So all these mushrooms which have which have gills on their underside, which are these lines in a circle, right? They are called gilled mushrooms, and they are called agaric type. So here is a gymnopilus, which is also a saprophyte, and there is this Satharella, which is again a saprophyte. Then we have polypus. So other than these gilled mushrooms, this is some another very common type of mushroom, which from its morphological stature, it is called a polyp. And these are generally these D-type disc, half disc shaped mushrooms, which come out of generally dead trees or small twigs. You will find small polypus on them, or you will find them growing on live trees also. So there are certain polypus which are parasitic by nature. Then there is jelly type mushroom. Sir, it's going well, right?
Yeah, perfect. No problem. Go ahead. Yeah.
Okay, sir. Thank you. Then there are jelly type mushrooms. I don't know if you are sure about these kind of, like, I'm sure this first one example, Auricularia, Auricula jude, it is one of the most common mushrooms that you see in the entire Western Ghat belt. I'm sure it's everywhere. It seems to have a cosmopolitan distribution. Uh, yeah, because I see it everywhere. Wherever I've been, I've seen this mushroom. When I was in Himachal, I saw this. When I was in Mumbai, I saw this. In Ahmedabad, I've seen it. In Baroda, I've seen it. I've seen it in Bangalore. Every time we go to Cubbon Park as a part of the Nuvedo foraging walks, we find Auricularia is there. And then there are sometimes other confusing species that will look like Auricularia, but they have a different morphology. So you see how close up these pictures are. This particular Exidia species, which is on the right, this will be like the size of my thumb, almost this much. So the point is, it is very important that you get as close to the mushroom as possible so that you can identify it, because a lot of pictures that people share about mushrooms, it's like so far away that even an identifier can sometimes not make out at what is he looking at, because if these both mushrooms, I keep them far away, they will somewhat look very similar. Then there are coral mushrooms. Like we have corals underwater, these mushrooms sort of mimic that morphology, and hence they are collectively called as coral mushrooms. This is the first ever coral mushroom on the left, extreme left, that I saw in Himachal. I'm not sure of the ID, and hence I have not written about it. It may be a Ramaria, but I have not written about it because I wanted to be sure about whatever I'm sharing today in this presentation. Then this is from Wayanad, the second one. It is called Claulinopsis, which we saw a lot of them in our Shroom Sabha foray in Wayanad. So yeah, Wayanad is beautiful. It has a lot of mushrooms. We also saw the Pleurotus giganteus, which is a very big oyster and which is edible. We could, we were like 25 people, which had like at least two nice cubes of mushrooms like this, and 25 people could eat it. It was that big, this big. Then there is this Clavaria mushroom. So these can be either growing out of soil or out of wood, decaying wood. Then another very famous edible and non-edibles also are puffballs. So you can see Lycopodon perlatum over here, which is an edible mushroom, but not always. So I'll come to that later on. Then we have Geastrum species over here, which is called the earth star. If you know about the Rugra mushroom, which grows in Jharkhand in association with sal trees, and a lot of finds have happened in Karnataka also, where they are associated with hopi trees. They are also a type of puffball because they are all like balls, puff balls. So it's like that. Then there are bolids. Most of the bolids are mycorrhizal in nature. There are certain species of bolids that we will see these days in ID groups or if you are a part of it, which is called the phlebopus, which is can act as a saprophyte or is a saprophyte. But most of the bolids are mycorrhizal mushrooms, and some people ask if you can cultivate bolids, but you cannot cultivate bolids as of now because if you want to look for a very saprophytic kind of nutrition, they will be sort of very host specific. So people are researching on this. Then there are stink horns. Now, as the name suggests, stink and horns. So they do look like horns. There is a very famous genus in this uh, type of mushrooms called the phallus species because they look like phalluses. And why are they called stink horns? So stink, where is the word stink? Like where do you apply it? So you see this top of this left mushroom, it's phallus luteus or something similar to it, which we found in Kaban Park last year. And this mushroom on top has this sticky liquid which smells. It's called the gleba. And this smell attracts a lot of insects. And if you see this mushroom popping out today, by tomorrow, you'll see that a lot of insects are sitting on top of the gleba. That is because that is the spores of this mushroom are also spread. Like it attracts the insects through the smell. You'll see flies, insects. So yeah, there are a lot of different type of stinkons. I've mentioned three of them here. This last one is a still growing phallus indiciatus. Generally, this skirt that it has will be almost touching the ground, but it's not in this case. Then there is this Lysurus species. So stinkhorns look very weird. To some, they look very beautiful. To some, they look very weird. It has kind of a gothic feeling to them also. Yeah, they're fun to watch, but they stink. Sometimes they will stink so much that if you are standing near a stinkhorn, but you don't know that there is a stinkhorn beside you, and if you have a good nose, you may be able to say that okay, there is a stinkhorn over here. Then we have cup fungi. So these are another type of mushrooms. They are really small. This is a Sarcosypha species that I found in Himachal. This was the time when I did not even know what this is. I was very happy to see the color and I could somehow figure out, okay, it's a mushroom. Then I got it ID'd from experts. The one on right we found in Wayanad, it's called Cocaina tricoloma. Um, Cocaine is the genus name, and tricoloma because it's hairy. So trike is it refers to hair. So a lot of mushroom naming. Generally in nature, it happens that people name things after how its morphology is or how it looks. So tricoloma is somewhere related to hairy. So before we dive deep into what understanding different parts of a mushroom, it's also very important to know that substrates play a crucial role. So what is a substrate? Substrate is basically what is the mushroom growing on or what is the mycelium feeding on, right? So it will mycelium will feed on something. Say for example, it is getting into a dead wood. It will slowly eat up the dead wood, yeah, decomposing it. And once there is enough mycelium for it to make fruit body, it will make a fruit body, which is a mushroom. So this is, I found it 2 days back. Mushroom on the left, it is a Coprinellus section domestici. I will get to it. Like how can you go about identifying it? So it's on a wood substrate. Then you will see mushrooms growing out of elephant dung, rhino dungs, cow dungs. So one of the example of that is Deconica coprophylla. Coprophyll is again related to dung, so that's how it got its name. Then there are mushrooms which grow on dead leaf litter. So Marasmius capillaris is an example for that. There are, as I said, there are, if you are in a city, you will see a polypore growing on a live tree. So you have this Ganoderma species growing on a tree over here. I found this in Kaban Park 1 year back. Then there is this very interesting, eye-catching type of mushrooms called entomopathogenic mushrooms. Entomopathogenic. Entomo meaning related to insects. Pathogenic means disease-causing. So you can see this mushroom called this Gibellula sp. I don't know if that's the pronunciation, but Gibellula or Gibellula, whatever, something like that. It has infected a spider. So this particular genus infects arachnids or spiders. Then you have soil as a substrate. Hygrocybe species, they are also called wax caps. If you can see in this image over here, it's shining because they do have a shiny feeling, and hence they are also called wax caps. If you see a hygrocybe in soil, you will be very sure it's a hygrocybe because of the striking colors it has. It has its own beauty. As in this picture, also you can see it looks like there are some angels, in just soil. So they are very beautiful. Then another substrate association is termitomyces. These mushrooms are again foraged like crazy. Sometimes people don't even wait for the gills to open up and release. Like they will just harvest this mushroom as soon as they see it. This especially happens in the western belt as of India, as I know about it, in Maharashtra, and even in Karnataka. So basically, very cool thing about this mushroom is that these are actually sort of cultivated by termites. So termites, they forage for wood and they will eat that wood. They will come back to their colony and they will vomit out or regurgitate the wood. So somehow from the termites microbiome inside their gut, something happens and this wood is now ready for the fungus to colonize it. And so much wood is then collected that someday this huge million unit termite colony will start making mushrooms and they will pop out from the ground and we will enjoy eating them. So that's what termitomyces is. And another association is parasitic association. So in this image, you will see that there are these small balls on this wood. So that is a hypoxylon species. And this species is then parasitized by this beautiful jelly type looking mushroom called Tremella fusiformis. Tremella fusiformis has a lot of application in the beauty industry. And China is one of the biggest cultivators of this type of mushroom. It is a parasitic mushroom, and hence in nature it will parasitize hypoxylon species. And the most beautiful associations of all is the mycorrhizal association, which is between roots and fungi. Most of the philosophical aspect of how amazing mushrooms are, I think, comes from this association. A lot of cultivators have been also trying to grow mushrooms which form mycorrhizal associations, but it's not very easy because one thing is they are very host specific. Some mushrooms can act as saprophytes, that is, they will change their mode of nutrition from being mycorrhizal to being saprobic, that is eating on decaying wood, but that is all still being studied. Uh, so if you would have seen that some people say that mushroom mycelium is connecting all the trees, right? So it is these sort of mycorrhizal relationships which will connect the main mother tree with its next generation trees, and through the mycorrhizal network the nutrition is passed. So not only does mycorrhizal association help nurture the forests, not only does it give us very nice edible mushrooms, but it also nurtures the forest, and which is a very key. They play a very key role in the nurturing of the forest, and hence keeping it all good for the forest life. Okay, so now let's get into the morphology. The most common type of mushrooms that we think about when we hear the term mushrooms are these gilled mushrooms. and the agaric type. So again, quickly looking at the various characters and the forms and the parts of a mushroom, we have the cap, we have the gills, we have the attachment to gills also, which I will come to later. We have the the partial veil or the skirt, also called the annulus. Then we have the stipe. We have the base part, which will have a vulva. In some cases, it will not have a vulva. Some will have a different kind of base. So we'll come to that. And then there are mycelial threads at the okay. So before, I hope some of you are laughing at this image now, because if you are into an ID group and if you don't send right pictures, the people who are there will send you this and say, "Bhai, please send good pictures." The reason being, why do you need to send good pictures? I think it will be clear after this presentation. But if you want to note this down, you can take a screenshot or picture of this in the next 5 seconds, and then we'll go ahead. So use these tips for us identification purposes. So 1, 2, 3, 4, 5. Okay, next slide now. So we'll start with the cap. Okay. So there are different type of cap morphologies also. So there are some which are cylindrical, which are conical, some are bell shaped, some will have rising on top, which is ambonate, some are convex, some are plain, uplifted, umbilicate, depressed, funnel shaped. So I'll give you some examples so you can know about this. So a cylindrical cap. If you know about the shaggy mane mushroom or the ink cap, the mushroom which becomes ink. So that is this. This is that mushroom, but it is not right now in its prime stage. It is still growing, and hence this cap looks very cylindrical when it is coming. So that this is an example. And see, like once we see more images, you will figure out that why is the importance of cap and the stature so important in understanding mushroom morphology on the field. Then we have conical caps. So this mushroom is conocybe, and cono means conical and cybe means cap, related to cap. So a cone cap. They are also the common name of this is cone caps. So okay, you may think that something will happen and mushroom will be touched and its morphology will change. Okay, that is a special case. But how many times do we find a mushroom just like by sight? You need to look for them, right? So most of the mushrooms maintain their stature, and hence it is very important that their documentation is done in the right way. Again, if you see this mushroom actually is the size is like almost not more than 7 centimeters. So you really need to get close to a mushroom to click a good picture of it. Then you have bell-shaped caps. This is Coprinellus section micaceus. So you can see like comparatively, all these mushrooms have different caps. This is like a bell. Then you have ambonate caps. This is a Tomatomyces that we saw in Sakleshpur. It was very fascinating because all these mushrooms are supposed to be very big, but we were on a hill and all the mushrooms that we saw were like minute in nature. It's like the Lilliput of mushrooms is what we called it there. So Tomatomyces mushrooms, they are also characterized like from the eye. Just if you look at the cap, sometimes you can make out. If you see this uh, bow on top, you can make out it's a Tomatomyces if it's coming out of soil. But still, there are more features that you can use for identification. So again, the cap is very important. And you see, it's not all top angles. These are all side angles. Okay, so that's very crucial. Then there is umbilicate cap. Umbilicate is almost like a bell, but on top it will have like a fall. So this is Marasmius rotula, which grows on decaying wood, which is an example of an umbilicate cap. Then there is convex caps. So now this can be confusing. Some of you may think this is also a bell, but bell is like more close like this, if you can see my hands. And convex is like a little bit more open than a bell. So it forms like a convex mirror type, which we studied in school most of us in 10th standard. Convex, concave mirrors. So convex mirror. So this is an agrocype species, again a very common field mushroom which you will see a lot of times. Most of the times, people will send ID request. It will be this mushroom because it's very much visible in fields. Then there is a depressed cap. So depressed cap will have a longer trough in the center, and from compared to an umbilicate cap, this is an example of Russula parvovirescens. Uh, Yeah, the Rasulas are very beautiful. So again, see depressed cap. So mushroom capturing the mushroom's cap morphology is very important for identification. So after the top part, which is the caps, we go to the side of the caps, okay, which is called the margin. So there are very different sorts of margins, which do have very specific terminologies, which I will not go into because it will become very confusing. And to be sure, even I don't know all those names, but till now I have developed the eye to differentiate them. So let's see some examples. So this is a striate cap margin. This is a Leucocoprinus burnbomi, which we found in Kaban Park 2 years back. They are yellow looking, nice looking mushrooms. Some people will find them growing out of their plant pots also, and hence they are also called plant pot dapplings. Don't worry if they are growing in your plants, by the way, they are fine, they are safe. You should not eat them, but yeah, they are safe for your plants. So striate cap margin, if you can see, there are standing lines kind of structure at the edge of this over here, right? This is also an identification feature, by the way. So hence it is very important that you go very close. I have another example of a Leucocoprinus here. So you can see these edges of the caps. If you have good network, you will be able to see that there are lines on this. Other than the decorations that you see on this, there are lines. So these are called striated cap margins. And this is one of the very crucial feature to identify Leucocoprinus caps. And Leucocoprinus again is very commonly found mushroom. Then we have smooth caps, smooth cap margins. So macrocype gigantea. This has been also popping up in a lot of parts in South India, like from Maharashtra to South. Also in Sri Lanka, where it was like there is a paper of it being cultivated. So you can see this cap margin over here, it has nothing. It's smooth, like that's why it has nothing basically. So smooth cap margin. Then we have wavy caps, like waves. So you will say, okay, no, this is happening just because, okay, it's like that, it's like that. No, this is again a morphological feature. And as mentioned before, that caps can have morphologies which are very crucial to document. And most of the mushrooms, if they are growing without any disturbance, will maintain their statures or their shapes. Then there is this mushroom called Paneolus papilionaceus mushroom, also called the petticoat mottle gill. If you see at this cap very closely, you will find that it has a nice decoration over here, which looks like a petticoat. So this is a very this is an identification feature for a very for a lot of Paneolus, because if a Paneolus there is some other Paneolus which is not in the Papilionaceous group, it will not have this petticoat type structure at the margin of the cap. So again, you need to get close to the mushroom and you need to document it. Sending pictures from far away or trying to understand morphology from far away does not really make sense. Then there are cracked caps, which are radially cracked, which is again a cool feature that is in termitomyces. This we found in Sakleshpur. Yeah, so that's like the underside. You can see that's cracked, and you can see the underside, and from the top it looked like this. This is the same specimen from two different angles. From these pictures, I want you to also understand how close you need to go to a mushroom. Okay, I'll keep repeating that so that I hope whoever is seeing this will learn and send better pictures also and understand morphology for your own sake also. Other than this, there is this feature called hygrophanous caps. So hygrophanous is basically used for mushroom caps when it tells about the amount of mushroom, like the amount of water absorbed by the mushroom cap or by the mushroom cap. So in this picture, you can see various gradient colors, okay? But these are all the same mushrooms, okay? So, and it is also an identification feature for the genus Sathyrella, for example. So this was growing on a bark, and I saw around 200-300 Sathyrellas growing out of the same bark, and all were looking different because they are all hygrophanous. So different, each cap took different level of water. Okay, absorbed, some absorbed it, some released it. So you can see dry patches, you can see really wet patches. Then you can see dry patches at the margin because the margin is much thinner compared to the thickness of the central part of the cap. So that was caps. Some caps will also have different decorations on top, and hence that is also very important to capture. These structures, which look like waves of water, are called squamules, and squamules are differently placed on the caps with various shapes, which is also very important feature. On the left, you see this mushroom, which is Clarkinda trochoides, which is a poisonous mushroom, and to an unaided eye or to someone who is not very experienced, this can feel like very similar, okay, but it's not. The left one is a poisonous one and the right one is a delicacy. It's enjoyed by people eating. They enjoy Macrolepeta procara. Even I have eaten it. A lot of people who enjoy eating foraging mushrooms would have eaten this mushroom. And a lot of people also get confused with this mushroom and they forage the wrong mushrooms, which are poisonous, which I will also cover in some time. Other than this cap part, there are remnants of the universal veil. Okay, so there are two types of veils in mushrooms. One is the skirt, which is the partial veil, and then there is the universal veil. So you can see in this diagram that these mushrooms start as a complete closed structure, and then this cap will push out. Okay, so what happens is the top part of this egg-like structure, some of it will get stuck to this cap, and as the cap expands, this will crack out and it becomes the universal veil remnants, which are also called vellum in which are also called vellum. So you can see in this that this particular mushroom, it started as like one complete structure, and then this stipe is pushing it out. You can see that at the bottom, and when it will mature, it will have this red remnants on top. So this feature is also very crucial when you are identifying a certain type of, especially in the family Satyraceae. Coprinopsis is this mushroom, and we found this in Kaban Park, Bangalore. More examples of different types of vellum. So you see red vellum on top. In this, you can see a dark brownish vellum. This picture, sorry, I had used in an earlier slide. So these are from the same section. So from genus to species, there is a special part in between, which is the section, which talks about a lot of species with common characteristics, like you group them together. So it's called section. So if you see Coprinella section domestici, does not mean that this species name is domestici. Since it is section, it comes in that section. It can have a different species name, but they all fall in the same category section. And then if you see the one on the right, these small uh, vellum particles are also a part of the universal veil, and this is section Oreogranulati. And since granulati, you can make it granular. So these vellums are very granular in shape. So again, unless and until this person would not have gone so close to this mushroom, he would not have seen that, okay, it's Oreogranulati mushroom. So he went that close to get a good picture. So it's very important. So after the caps, we will go to the next part. We went from caps to the cap margins. Now we'll go to the underside. That is the gills. Another very important factor. In this, you can see, imagine you are seeing this mushroom just like this. So there is a central stipe which is over here. And then there is crowded type gills, there are closed gills, they are subdistant and distant. I'll show you some examples. This mushroom I found in Baroda, by the way. I think it is some lepista. I never got a positive idea on this, and it was so old back then that I also don't remember how nice, what are the features of it. So, but it's a very nice picture, so I used it in this slide. So, example of distant gills, Marasmiella species. You will find these growing out of trees. Yeah, you can see that the gills are very distant, like very far away. Another example is Marasmius rotula that we just discussed in that umbilicate cap part. See, the underside is also very striking. It has this nice weird attachment over here, which makes it, you can differentiate it from other Marasmius mushrooms. And these gills are distant over here. You can see these gills are distant. Then you have almost close to crowded gills of the Gymnopilus. So again, gill features can help you narrow down on the type of mushroom that you're seeing. And gill features you can only know unless you lift the mushroom or you yourself bend. So you need to do that physical effort to document it. Then you have subdistant gills like of Lactarius. This I found in Himachal. This time I did not even know what this mushroom is, but I was so happy to see these geometries in. This is also an agaricus. Sorry for not using a very clear picture, but this part you can see that how crowded it is. So this is an example of crowded gills where you cannot see the lower part of the cap, back part of the cap. Generally, it's like crowded gills. So after gills, the density, we go with the arrangement. So in this, I hope it's clear because of lack of light. You can see all these gills are touching from the stem or the stipe, it is going till the edge of the cap, all of them. So it's called equal gills, and it is a striking characteristic of Rasula. Yeah. Compared to this, we have unequal gills. So you have this one gill which goes all the way from cap to stipe. Then you have halfway. Then you'll have quarter way, right? So this again, comparing it to the last slide, full lines you see from the cap to the stipe, and in this you see some will be going, some are going halfway, some are going full. So it's also like a measurement. A lot of mushrooms will be like in 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. So that's again how you can connect music and nature. Then we have anastomose gills. This picture is not moving, by the way. Some of you may feel that, okay, this picture is moving. That's because of the details in this picture again, which was captured in my hand. So I literally took a picture like this. That's how near you need to go. So you have straight gills, which go from the cap to the stipe, and then you have cross gills also. So these are called anastomose gills, okay, which is also an identification feature. For example, sometimes if you want to differentiate between a marasmius and a gymnopus, which are very similar looking, you can use such gill characteristics also. Okay, from the gills we go towards the stipe now, and we stop there because this another very important feature is the gill attachment to the stipe. Okay, very, very important. So there are adnate type, there is adnext type, there is decurrent. So basically how the gill is attaching to the stipe, there are different ways in which it attaches. So there are free gills also. The button mushroom that you see outside in the market, the gills will not be attaching to the stem or the stipe because it has free gills. That's an identification feature for agaricus type mushrooms. Agaricus is for the genus Agaricus. Then you have decurrent gills, which will be going with the stipe. Okay, so we'll get into the examples, but this is a very important feature. How to check? Okay, how to check? So just hold a mushroom like this and slowly start tearing it. I mean, this is a very, if you don't have any tool like a knife, you can use your hands also. With some mushrooms which are not delicate, you can figure out gill attachment. So you see, I'm tearing this mushroom here, and then this is the attachment over here. And you see, it's not attaching. Yeah, it's not attaching. There is space over here where my pointer is. So that is the gill. Yeah. Whoever wants to go through this slide presentation again, I'll share it with you because now I'm going to rush. We don't have a lot of time. Okay, adnext gills. Adnext gills example is over here. You can see it is like slightly attaching to the stipe. This is a Mycena species. You can use this identification feature. With this, you can also see some anastomosing gills over here. If your internet is good and you can see it clearly. If not, it's okay. We are talking about gill attachment. Let's focus on that then. Adnext gills. Then there are decurrent gills. The one of the most new famous mushrooms in the market, oyster mushrooms, right? They have decurrent gills. Means this gill will start from the stipe and will run down start from the edge of the cap and it will run down to the stipe. It is almost coming till the near to the base, right? So it's that long. So that's how you can differentiate gill types. Then you have decurrent, subdecurrent gills. So compared to this one, which is running so much long on the stipe, some will not run so much, but they will run a little bit. So they are called subdecurrent. A lot of lactarius mushrooms will have subdecurrent stipe, gill attachment. Sorry. Then free gills, as I discussed about the button mushrooms. The button mushrooms are Agaricus bisporus, and you can see these gills are not attaching to the stipe. I mean, it's very close, but it's still not attaching to the stipe. So if it is not, it is called a free gill. So here is a close-up of two different gill types, one on the left, one on the right. See how crucial the gill attachment is for identification. Okay, I can see the colors are different and everything, but you can see these are free gills and this is adnate type of gill attachment. Adnate is it's like fully attaching, the gill edges are completely attaching, but they are not running down, they're just attaching. So free gills, this is a Volvopluteus gloriocephalus and this is an agrocybe. Both again very common mushrooms that I saw them growing beside each other in soil. So both of them grow in soil. Agrocybe are called field caps. Okay, now since we are talking about gills, there are different undersides also. So some will have gills, some will have teeth, some will have ridges, some will have pores. Why is this important? Let's talk about it. So teeth type undersides, this is a hydnum species. This you will find mostly in temperate regions. I have not seen this myself yet. So underside has teeth, they are not gills. So again, if you just go on top and you send someone a picture like this on the right, they may not know what it is unless you show them, oh, teeth, okay, it's hydnum. That's how you can sort of figure it out. Then you have ridges. This is a chanterelle mushroom, which is one of the favorite mushrooms of foragers. Now, this mushroom looks like it has gills, but they are not gills. These are actually ridges on the underside. Okay. So there is a mushroom called Hygrophoropsis, like this one on the left, which does look like a chanterelle on top, but it's called a false chanterelle. And here is a comparative picture of this mushroom chanterelle on the right having ridges and this Hygrophoropsis having gills. And so I've just written Hygrophoropsis, also known as false chanterelles, which has gills, and Cantharellus species, which is a chanterelle which has ridges. So undersides are crucial. Undersides can only be seen if you bend or if you pick up the mushroom and cut it and send a picture or look at it. Then you have pores on the underside. So recently, bioluminescent mushrooms have been attracting our eyes and our minds. A lot of species in this genus, like for example, Philobolitus manipularis is a bioluminescent mushroom. It looks very beautiful. I don't have a picture right now, but you can Google it up. Philobolitus manipularis. So they have pores on the underside, like this. They are not gills; they are pores. Again, they eject spores from their underside, but from a pore type mechanism. So after gills, now we go to the stipe or the stem. Okay. So now the stipe or the stem is also ultra important. Okay. So for example, This mushroom on left is the parasola, and this one is a tulosis. Now this tulosis is brown cap. I understand a lot of tulosis have this similar color on cap. One of the striking features between tulosis and parasola is that tulosis will have this hair-like projections on the stipe, whereas parasola has a clean, clear stipe. So if you send, you will see this in fields, and you will try to figure out what it is. But unless and until you don't go to near the stipe, and these are very small by the way, they are not very big looking mushrooms, also very delicate. So you really need to go to the stipe and figure it out. Some more examples of stipe. These Bacteria phalloides, for example, has like a brown fibrous stipe. This is Amanita manicata. So Amanita manicata, also called Saproamanitas or Amanita section lapidala. I found this in Bangalore, but this picture is not from that one, but it was same mushroom. You can see how it has decoration on the stipe, which is again a good feature for identification. One of the most crucial features for people who look for edible mushrooms in the field is comparing Macrolepiota's type and Chlorophyllum species type. Okay. So Macrolepiota procera, which is an edible, will have this decoration on the type, like it has, sort of marks like snake skin. Whereas Chlorophyllum, which is a poisonous species, which looks very similar, by the way, from the cap, will not have any decoration on the cap. Oh, sorry, on the stem or the stipe. So that is one very important identification feature. Most of the people will send edible mushroom inquiry and click picture from top where stipe is not visible at all. A lot of people have eaten this wrong mushrooms and they've had gastrointestinal distresses also. Then from that stipe part, we go to the annulus or the partial veil or the ring or the skirt. Some mushrooms will have it, some will not. Leucocopenus cretaceous, again, this I found in Ahmedabad. You can see it has a very nice looking stipe, very nice looking picture, full of decoration, squamuse on top. Then we have Sathirella species, they don't have. Some actually, there are some which has been found to have stipe, but generally they don't have. So you can see that in this picture, we also have the underside and the stipe is clearly documented. So you can figure out what mushroom it is. It does not have a stipe. Then there is Clarkeenda trichodes, which is another very poisonous mushroom, and it has a very beautiful skirt. As beautiful it looks, it's poisonous also. So it's very crucial to document it, like how the skirt is. Entaj, one of our my new friend from Microasia, and he's a researcher on agaric. He mentioned that mushrooms have double annuluses also. So there are some agarics which have double annuluses. They fall in the Xanthodermatiae section, and most of them are poisonous. So again, capturing the type is very important. Then we have Lugo agaricus rubrotinctus. You see, all these types feature are very different. So again, type is a very important morphological feature. Stipe and annulus. Sorry, annulus is a very important feature. More stipes and annuluses here, Microsaliota. Then we have Leucocopenus fragilismus. Okay, now this mushroom over here that you see, if I would have taken out this annulus, no, you can also think of it as a parasola like this, right? You see, it's very similar looking. But because it has annulus over here, it was easy for me to figure out, okay, this is a Leucocopenus fragilismus. Then our famous mushroom Amanita species, our emoticons, our Christmas fairy tales, so many stories around it. One of the most mystical mushrooms that exists on the planet, Amanita muscaria. They also have annulus or a skirt. Then from the annulus, we go to the base of this type. So some have a volva, some have a bulbous base. Again, Volvopluteus gloeophalus. It has this volva at the bottom, this sac-like structure. This is again a bigger matured specimen. If you can see a ring over here, not a great picture, but fine enough for someone to say, okay, it has a sac at the bottom. So it has an egg-like volva. Some mushrooms will not have egg-like volvas. They will have a base which is bulging out, called a bulbous base. Okay, this left one, Volupluteus, was found in Kabanpak. This one I found near where I work in Nuvedo, and it's called Chlorophyllum brunnium. And this is not a, it has the base close up. It's not a sac, but it's just like the stipe bottom is bulged up like a bulb. So then there are egg volvas, there are bulbous bases, and then there are pseudorhizas. What is that? So they are like root-like structures which will go into the mud from where the mushroom is emerging. Termitomyces species have pseudorhizas. Uh, I saw Arun Kumar sir's presentation, and sir explained how this is a very important feature in identifying the base. Like by the base of the termitomyces, the type of color of the pseudorhiza, you can figure out what uh, species it is in the genus Termitomyces. Then, good to capture it. If you can dig it out nicely, slowly, it can be a hectic process for some if the soil is very tight. But yeah, patiently dig it out and document it. Then you have Eudomancilla radicata. They also have a nice pseudorhiza. So that's again a identifying feature. Then some mushrooms have a discus base at the bottom, like this Mycena has. So they have a disc-like attachment at the base. This is also a mycorrhizal mushroom. It has been documented in the Western Ghats. If you see a lot of posts of go to Western Ghats, they are bioluminescent mushrooms. I think mostly they're talking about Mycena chlorophyllus, which is this mushroom. So it has a discus-like basal attachment to the substrate. Then some mushrooms will have, especially Coprinellus section orogranulati and Coprinellus section domestici, have this hairy fire rug colored mat called ozonium. So this is again a characteristic feature of this particular section, Coprinellus section domestica and Coprinellus section orogranulati, and it is a very important identifying feature for it. So the base of the mushroom is also very important, and to look slightly around it. So from base, we go now to the bruising and staining, which can also help you identify a mushroom. Some mushrooms, when harmed, will change the color when it is cut or damaged due to oxidation of various compounds present in that mushroom. In bolides, there is a compound called gyrosinin, which bruises blue when it is hurt or damaged. It's a bolide identification feature where you damage it, and you sometimes it will oxidize very fast, or it will change color very fast, or it will change color slowly. And that time gap is also very crucial in figuring out how do you, where, in which genus will you place that bolide type mushroom. Then the Agaricus bisporus, the button mushroom, is a very common edible that we all know of. But there are other Agaricus which are also non-edible. So the section Xanthodermati, which I talked about as having double annulus, if you hurt them, you will see this yellow color secretion, sort of bruising coming out. If it is getting yellow, it is a poisonous Agaricus. I am not saying that if it is not getting yellow, it is not poisonous. But if it is yellow, it is. I'm not saying that if it is not getting yellow, it is poisonous or not. But if it is yellow, it is definitely poisonous. So Agaricus section Xanthodermati are said to be yellow staining Agaricus also, and they are not edible. So check for bruising. Then psychoactive mushrooms also bruise blue. Uh, so a lot of people say bolides are psychoactive because they bruise blue. No, that blue bruising is because of some other characteristic compound and characteristic feature of a particular compound, and blue bruising of psychoactive mushrooms is another characteristic feature compound. So if you are on the field and if you want to figure out if the mushroom is psychoactive or not, you can just bruise it and check if it is turning blue or not. Definitely, they don't look like bolides because bolides have pores on the underside. It has some exceptions. Best is to get it ID'd from an expert. Then some mushrooms, when hurt, bruised the gill part or some the stipe part, they will secrete milk-like secretion. Lactarius, lact, as it suggests, milky. So lactarius, when bruised, they will have these milk-like secretions. a very nice, beautiful looking Lactarius indigo, which is blue in color. It also gives out indigo in color, and it gives like indigo, like bluish type bruising. So again, take the mushroom in hand, sort of play with it. Don't like finish it up completely, but understand it. Okay, so from that, another very important feature is the spore color. Okay, so mushroom are best identified when they are at their matured phase. To make it funny, I call it that let the mushrooms reach their puberty at least before you pick them up or you identify it, because it's the safest way also. So some mushrooms gills color will change, and they will tell you about the type of spore color it has. So on the left you see Paneola species which has black spores, which is called the mottled gill mushroom also, because this is like a mottled gill pattern and it has black spores. So that is one identification feature, very important. A lot of mushrooms can be figured out by the spore color. I will come to that. Then there is the toxic mushroom. Some people call it the vomiter also, because it can cause gastrointestinal distress. Feature to identify this mushroom from other edibles, this being a poisonous one, is green spored, green mushroom, green spore color. So be careful. Don't eat a mushroom which has green spores. Then we have another type of mottled gills, like Paneolus had black. This has dark brown. It's called Lacrimaria lacrimabunda. Very nice picture I had of this, so I shared it on this presentation. Then there are dark pink spores of Volvopluteus gloriocephalus. I've shared this mushroom 2-3 times in this presentation. See this underside, it looks dark pink. And if you print it on a foil paper, you can check out the color in a much clear way. So now, as we saw, Chlorophyllum molybdites has green spore print. Chlorophyllum brunnium, which I again found near where I live in Bangalore, has white spore print, and I printed it on the foil paper. This was this big, very beautiful looking spore print. People also make spore print art. So one idea is you can get different looking mushrooms and make some spore print art. Why not? My favorite, one of my favorites, because it's blue in color and it has beautiful pink gills, Entoloma. Entoloma, also called pink gills. Look at how beautiful this mushroom is. I found it in Wayanad, and it has pink gills. You can see it has pink gills. So it's also in the subgenus Leptonia under Entoloma genus. Then you have the king stropharia, or the wine caps. Recently, someone shared a picture of this from Himachal Pradesh. So they have purple spores. Very strikingly, you can figure out wine cap, but spore color is also important. Then you have Gymnopilus species which have rusty brown to orange spores. They are also called rust gills because it looks like the gills are rusting because of the spore color. If you can see in the image, you can see like spots of rust. That's like spores gathered at some place because of like water putting them together. Okay, so that was agarix. Now we quickly go through polypose, because that's another very common mushroom that we see in the nature or just outside. Everything is actually nature. So polypose, how do we go about identifying polypose? Before that, I just want you to know that they can be very huge in size. This was so big that which I saw in Himachal, and that time I did not know this is a Formes fomentarius. Okay, and this was so big that if it is raining, I can sit under this polypore and I can be completely safe. Like at least my upper body will be safe from rain. It was that big, and I also actually harvested it. It was 3 kgs or so, very heavy. Okay, so how do you differentiate between two polypores? You may think that these two are the same mushrooms, but it's actually not. One of them is a sterium and one of them is a tramites. Again, both of them are very commonly found. So how do people identify if it is a genus sterium or if it is genus tramites? Polypores can sometimes be identified to genus level, sometimes, not always, by their undersides. So if you see, this is on the right is the top side of a sterium, On the left, it is underside of a stereum. It has a slightly off-white color, and pores are not visible to the naked eye. Someone also saw it under a microscope, like not very high magnification, and I think 10x or something like that, and they could not see pores. So if you don't see pores, it is generally a stereum species. But if you see something like this decoration with pores, then you can call it to be Tramites. Okay, so see, polypores can be very confusing. Most of them are only identified after doing microscopy, which is checking them under a microscope, or doing a DNA sequence. But you can still sometimes figure out from their undersides. So this is like a Tramites underside. That is a cultivated Ganoderma. So you can see the size of the pores is sort of different. I will not go into the measurement because again, we are looking this from a very field perspective. So it's more about training the eye to see the differences right on the field. So pores which are smaller than this Tramites, but they are not so small, or it's not that you cannot see them from a naked eye. Then there is microporous. I think microporous have even smaller pores. If you can see it in this, if you have good internet connection, you can see it in this also. There are very small pores. If you can't see the edges, you can come near the stipe and see. So micro, small, very minute, porous is how this genus gets its name. Then they have some polypores are very weird undersides. And this is another very one called Earliella scabrosa. So, and then this is another mushroom called hexagonia, which has very big pores, hexagon, almost like six sides. So hexagonia. That's how it got its name. Again, a very common find in, at least we have seen a lot in carbon park. So I'm sure you will be able to see it around also. So whenever you see a polypore like this, just flip it, see the underside. You may be able to figure out what mushroom it is. And these are some undersides that we saw in Shroom Sabaphoris. So not very clear because it was a phone picture I took. So you can see this undersides are different. This is, you can see gill type underside over here, which is a gilled polypore. So see, mushroom breaks rule. There is gill and polypore both combined in one mushroom, and it is Tramites betulina, which has gills as the underside. So mushrooms do break rules. Okay. This is like a rotting sample of Ganoderma. This is Earliella scabrosa, which this one over here again. And this is another Tramites, maybe flavida. Okay, next slide. Then we have puffballs, another third type of stature type category, very common. So how do you identify puffballs? Puffballs can be identified by the substrate they are growing on. Most of them will be growing on soil, but there are certain type which grow on wood, and they have some very similar morphology to some slime molds also. So a cross section of a puffball is very important. I myself have eaten a lot of puffballs in Himachal again. So how did I know that it is edible or not? Okay, so with puffballs, it's not like all puffballs are edible at all stages of life. Okay, if you open up a puffball, cut it, and you see the cross section, if you see it is white in color, completely white, then you can eat it. But it starts to yellow, then turn brown, then turn dark brown, and gradually black. So if you take a cross section, if you see yellow color, you should not eat it because now it is starting to become poisonous. Okay. So lycopodon, I ate it 1 year back and I'm presenting it to you. So it's on you if you want to risk it, but always take cross section. Why did I say if you want to risk it? Because if you are scared, ki, yeah, I'm not sure, don't eat any mushroom if you are scared about it. Okay, it's not compulsory. But if you want to eat it, you check the cross section, you check it inside. If it is completely white, cook it that day. Then there are big lycopod, big puffballs called Calvacia. I have not seen this gigantea. I only saw it once in Himachal, which was almost like this size. And Mushrooms are not supposed to be eaten uncooked, but I actually tried it uncooked and it almost tasted like a boiled egg. And I went mad after that. So, yeah, I have been inspired by mushrooms when I didn't know anything about that. One of the reasons is this mushroom, Calvasia. Again, the cross section, you can see it's clean white. A lot of people who find these mushrooms, they use this as a pizza base. So I want to try it someday also, if I find it again. Then why are cross sections important? So again, if you look this thing from far, you will say, okay, it is a lycoperdon or it is some other puffball. But if you cut it, you will find out that, oh, it's not that, it's a phallus. So phallus species like stinkhorns, when they are in their egg-like shape, they look very much like a puffball. So cross section is very important. So you will get a puffball and at home you'll cut it and you'll figure out, oh, it's not a puffball, it's a phallus. So yeah, that's how you can figure out. Cross sections of puffball identification is very important. Then you have Scleroderma citrinum. This mushroom is in the West. You will see people will say it's not edible, but somewhere shared it on the Mycoacia group also that these are edible mushrooms. Under edible, this mushroom was mentioned. I have personally not eaten, so I will not comment if it is edible or not. But some of the experts, one of the experts told me that we Indians have a different immune system. I'm not sure about it. But yeah, if you have eaten, if you are eating it, okay. And if you have not eaten, I'm not suggesting anything. But some say this is edible, it is not. Again, cross section of it is important to get it identified. Scleroderma citrinum, another type of puffball. So now we are almost to the end of this presentation. Again, see, IDing and edibility are very much close together. Okay, till it's not ID'd, you cannot say if it is edible or not. And hence, I have shared some common mistakes that people make and end up poisoning themselves. One is Pleurotus ostreatus versus Omphalotus nidiformis. So on the left, you see a Pleurotus ostreatus. On the right, you see Omphalotus nidiformis underside and top side. Now they are very similar. Okay, so how can you differentiate between them? If you are in doubt, if in doubt, throw it out is what you can remember. But if you want to figure it out, also what you can do is Omphalotus nidiformis are bioluminescent mushrooms. Some will have very faint bioluminescent, but some will be very prominent. So at night you can check that. Yeah, another bioluminescent mushroom by the way. Then there are minor cap color differences, but they can be misleading. However, the mature specimens on top will have a brownish blackish tinge for Omphalotus, which is not present in Pleurotus unless it is too dried, because dried mushrooms will become brown on top. So be careful if you are looking for edibles and you are finding these type of mushrooms, get it identified from an expert before eating also. And you can figure out on your own also if you are confident enough. Omphalotus can cause uh, vomiting, but it's not very prominent. Does not last very long. It's not very poisonous, but it is still poisonous. If you don't want to vomit, don't eat it. Then again, I mentioned this 2-3 times in the presentation is Macrolepeta procera and Chlorophyllum molybdites. So Macrolepeta procera is an edible. People love eating it. I enjoyed eating it when I had it. As I mentioned in the type section, it has a snake skin, snake type skin. So that is an identification feature compared to a Chlorophyllum molybdites, which is a vomiter. Some call it a vomiter. It can cause gastrointestinal distress, diarrhea after 1 to 3 hours of consumption. So that is type over here. Another feature is this is green spore and this has white spores. So that's how you can figure it out. Then another mistake is Russula species versus Cantharocyte species. Some Russulas are edible. Sorry, some Russulas are edible. One way to figure it out is the gill attachment. So you have to check the underside, where Russulas will have adnate to sometimes free gills, whereas Cantharocyte virosa will have decurrent to subdecurrent gills. Also, the cap texture is velvety. If you find a Russula, you can take one Russula, throw it at a tree bark. It feels violent, but it is violent. But if it breaks down, it crumbles down, it is a Russula. It is an identification feature for Russula. So save yourself and you can dedicate one rasula to save yourself. Then this thing has caused a lot of havoc in the community where people look for psilocybes. This is just for knowledge purposes. Psilocybe cyanescens, which grows on wood, and Galerina marginata, which also grows on wood. So Galerina marginata, as we discussed, spores are important. Okay, the type of stipe is important. Galerina marginata will have orange to rusty brown spores, similar to Gymnopilus somewhat, whereas Psilocybe cyanescens will have blackish to brown purple spores. Okay. Um, Galerina marginata are also called funeral bells. So if you are looking for something like Psilocybe cyanescens, and if you eat Galerina marginata, it is possible that you will have serious effects like liver damage, kidney failure, and it may result in death also. So be very careful when you're looking for such mushrooms in the wild. Another feature for psilocybes are you can bruise them, hurt them, and they will bruise blue, which will not be the case with Galerina marginata. Mature specimens of Galerina will have like a dark colored stripe, which you won't find in psilocybes. If you hurt it, it will bruise blue or greenish blue. So these are some of the common mistakes that we make. We end up poisoning ourselves. So please be very careful. And that being said, send good pictures to identifiers. Okay, and don't ask for edibility, because after this presentation, maybe you can make out, oh, this is very crucial. And so for an identifier, it becomes a challenge that if he identifies it wrong, this person get poisoned. So it is, edibility is a good question from a human perspective, but it's a very challenging question for an identifier, is what I personally would like to tell you all. So, okay, that was the end of my presentation. I hope you are still there. Question answer time now.
Thank you, Vhyom. Thank you very much for that brilliant presentation. I hope you're okay. Vhyom?
Yes, sir. Yes, sir.
You drink some water if you want.
Yes, sir. Thank you.
I thought it was a very detailed, brilliant presentation, and you have shared your personal experiences and many original photos of from your own collection, right? That's beautiful. That's wonderful. Thank you very much. We'll have a question and answer session now. Please raise your hand if you have questions. Mr. Sahu. Okay, let me just unmute all of you. Mr. Sahu, please ask your question. Kemra Sahu, please ask your question.
Sir, I have a question. Yes, sir. Sir, my question is about Amanita manicata. You mentioned in your slide. So it is poisonous or edible, and also Microlepiota procera.
Can you repeat your question? I heard Microlepiota procera. That is a edible mushroom. But what did you ask about edibility? Can you repeat, please?
Sir, Amanita manicata is poisonous or edible?
Amanita manicata, I am not sure about its edibility. So one thing what generally people can do about it is once you get a positive ID, you can go to Google and figure out, you read a research paper or you ask an expert on edibility about it. Since I am not very sure about it, I will not risk telling you if it is edible or not. But I understand Amanita manicata has been occurring very frequently.
Okay, sir. Thank you.
Thank you for that question.
Thank you, Mr. Kaladaran. Please, do you have any question? Mr. Kaladaran? Mr. Aditya Arun, please ask your question.
Hi, thank you for your amazing talk, Vhyom, very informative. So I have a two-part question. The first part is that, is it possible, is there like a certain type of mushroom which prefers to grow in coconut substrate? So, the roots of the coconut tree, because I have two coconut trees in my garden and I find these mushrooms growing at the root of those. So can you identify if those might be poisonous based on where they grow? That's part one. The part two is that, the macrolepiota like now I know that I there was one of them growing in my garden, but I wasn't able to eat it because I wasn't sure. And now you tell me it's a delicacy. So does Macrolepiota also prefer the coconut substrate, or does it grow also in other types of substrates?
Okay, so first part of your question is talking about if that how if I can identify if something is growing on coconut roots and if it is edible or not, right? So for that, see, there is I don't remember the name, but there is someone who is growing a type of Coprinellus section cinerea in South India, where which is an edible. Okay, so that is there. If you can share the pictures, I can try and identify it, but I am not sure if it is edible or not. We can figure that out.
मैं लिए
Moreover,
मैंने पूरा पैकेट खा लिए भी आते आते बहुत हो गया अब। खाना खाना भी
Give me a second. Give me a second. Dr. Nadda, please mute yourself. You're creating a problem for us. Thank you.
yeah.
Please go ahead.
So okay, so if you in the presentation, Aditya Arun, if you saw in the presentation, I mentioned sections, right? Like Coprinellus section domestica, Coprinellus section micaceus. So there are times when there are mushrooms in the same group or clade which are nearby, but some are poisonous and some are not. So again, I would suggest to you that you get to a complete positive identification. You figure it out on your own if you want to eat it, right? Because if I tell you yes, and if something happens to you, I may also be partially responsible. So, the second question was regarding Macrolepiota. Macrolepiota. So it, according to all my field experiences, it has been growing in soil. It is not directly growing in association with coconut or another wood substrate. So it may act as a secondary decomposer like agaricus mushrooms. I hope I was able to answer your questions. And Aditya, I'm still telling you, get your Macrolepiotas identified from an expert before you eat them. Okay, please.
Yeah. Yeah. And generally, do they grow in large colonies or do they grow one or two in one place?
Macrolepiotas, they don't grow in like clusters. They can be growing multiple near each other, but you will be able to see them very prominently, like a single one standing. And another thing that you can differentiate is the stipe to cap ratio, which actually is slightly advanced. So I didn't mention it in the presentation, but the stipe of Macrolepiotas is very long compared to the cap. So that ratio, you can actually figure out if it is a Macrolepiota or not. But let's stick to this common, simple identification features for now.
Okay, thank you.
Okay, thank you.
Argit Gurbrand.
Yes, sir. Thank you for a wonderful session. I am from Meghalaya, Shillong.
Oh, yes. Hi, sir.
Yeah, I called you that day.
Yes.
So actually, like, I want to inquire regarding is there any identification kits like in the mobile apps or some form of a document?
So there is a very famous application called iNaturalist. Now, again, the thing is, see, if you do not click good pictures, you will not get good accurate identification. But I'm not suggesting to you that if you click the best pictures, you will get the most accurate identification, because these applications, they run on AI. They give you suggestions, okay, and they can give you suggestions which are poisonous, edible, psychoactive, non-edible, etc. So best is to get it identified from a human and not from an application. You can understand mushrooms through applications, because that is also what a lot of people who want to understand mushrooms morphology and identification do. But if it is a question about edibility, again, since sir, we discussed about that on the call, I would suggest you get it ID'd only. But iNaturalist is a very famous application which is used for all types of organism on this planet, and you can use that, iNaturalist.
Okay. And then second one, like, see, here in Meghalaya, we have so many edible mushrooms.
Right.
And recently there was a news like some people, they had consumed maybe the poisonous mushrooms, so they got allergy and some caused death also. So that's what I was like. We don't know really which one is a poisonous mushroom, which cause them the death or the allergy for them.
Hmm.
So that I need to contact you later on. Okay.
Sure, we can talk after this.
Yes, and regarding the protection protocol for edible mushrooms, the wild edible,
Hmm.
do you have the like what kind of substrate this and that?
Again, it's not substrate specific. There are mushrooms which will grow on the same substrate, which will be from, which are so similar that even in the, say, the phylogenetic tree, which tells you about how closely mushrooms are related to each other, they will be in the same clade or nearby clade and still be very, some will be edible or some will be poisonous. So again, get a positive ID. Do not think about commonalities and get down to edibility of a mushroom, which is because it is not safe. So I would not like to say I am an artist, but mushroom identification is an art. You have a lot of things that you need to consider before you get onto the edibility. Why is it an art? Because you need observation, you need to remember things, you need to be able to research. So it is a skill set, and hence using all these things you can reach to the edibility. So there is no straightforward answer, even if you break it down to the level of what substrate its preference.
Okay, yeah, thank you so much. Thank you.
Thank you, sir.
I want to just inform Mr. Kit that we have a couple of experts in your neighboring state in Assam. You can contact Dr. Arun Kumar Datta from Assam University and Professor Das from Borderland University for any queries related to identification, edibility, or poisonous mushrooms. You're most welcome to contact our speaker, Vhyom Bhatt. But if you want to send the specimens very fast to expert, please contact these people who are in Assam state, which is near to you. Okay?
Okay, so can you share the numbers?
Yeah, sure, we'll do that. Vhyom will do that.
Okay.
Yes, I will.
So
I will
much.
share that.
Thank you.
Okay, thank you. Dr. Rohit Sharma, please.
Thank you, Dr. Shah. Thank you, Vhyom. It was a very nice and informative lecture. I think very nicely explained whether it is stematitis, whether it is spore colors or the gill kind of thing. I wanted to ask that that thing you have found, that Scleroderma citrinum or Lactarius that you have found, were there any of them ectomycorrhizal also in the vicinity?
Yes, sir. So Scleroderma are said to be ectomycorrhizal species. That is very true. So basically, which means that they are in association with the roots of certain trees, and hence that is from where they exchange nutrition and they grow. But where I found Scleroderma citrinum, there were not other puffballs. It was mostly Scleroderma citrinum only.
And this Lactarius and other, these were also found to be ectomycorrhizal or no in your vicinity?
So Lactarius, sir, when I found them in Himachal, I found them in association with oaks, next to oaks. So, but there are people who are actually working on cultivation of Lactarius, which also makes them not always mycorrhizal. They can have specific hosts which are saprophytes. I don't have very much detail since I'm not researched much on them, but I did research on this particular mushroom called Tricholoма matsutake, and I read that under stress they do change their mode from mycorrhizal to being saprobic, where if they are not finding enough nutrition from the tree roots, they may start decomposing wood. So that being said, sir, Lactarius is an ECM ectomycorrhizal mushroom, but mushrooms are always breaking rules.
Yeah, that's true. That's true. Thank you so much. Thank you.
Thank you, sir.
Thank you, Dr. Rohit, for those questions. Dr. Rajesh Kumar, Managing Editor, Microasia.
Hello,
Please.
hello, Vhyom. Thank you, Dan. It was a fantastic presentation, Vhyom. We are so happy to hear you. My question is regarding the culturing of mushrooms. What was your success percentage in different genus, and how many genus you have cultivated so far? The second part of the question is how to maintain this fluorescence in cultivation. Do you have any experience regarding that? Or
Fluorescent?
yeah, fluorescent bioluminescence, I mean.
Oh, okay.
Yeah. You have come across such cases, or can we bring it into culture?
Okay, sir. So I will first answer the fluorescence question. I have myself still not cultured any bioluminescent mushroom, but there is a mushroom called Panellus stypticus, and I have read reports that the ones which were found in USA had the culture also glowing compared to the ones found in India, which had a little bit less glow. So I don't really know what is the direct mechanism to keep the fluorescence going. I'm sure it will be some chemical arrangement inside the mycelium which keeps it up. But since I have not had any direct experiences, I don't think I can comment on it more than that. But Panellus stypticus is something which has been showing different glows across different specimens. Also, the same is the case with Omphalotus nidiformis, which is a poisonous mushroom, as I mentioned in the presentation. Some can have dim glow, some can have like a very prominent glow. So it can be that if you culture it from a specimen which is having good glow, maybe you get better bioluminescence compared to which is having less glow, will have less bioluminescence. Is a very direct connection that I can make in my head. But again, that's not a tested answer. And regarding how many mushrooms I have cultured Macrolepiota prothera, I have cultured Gymnopilus purpuratus, I have cultured Colibia nuda, I have cultured Ganoderma from the wild, I have cultured Tramites from the wild. I have cultured some mushrooms, sir, and then cultivation. I've grown Ganodermas, I've grown shiitake, I've grown lion's mane, I've grown various types of oysters, uh, milky mushrooms or the Calocybe indica. Then yeah, I have been doing some trials with certain Pleurotus species also, like the Pleurotus giganteus, with which grows in Wayanad, which is a delicacy. Still not able to figure out the fruiting of it, but yeah, there are some trials, sir. I can't really get down to all the genuses right now. I'm having so many thoughts in my head. I would have cultivated, sir, 14, 20 different types of mushrooms.
Thank you, Mom. Thank you. Thank you very much.
Thank you, Rajesh. Varsha Nimbalkar, please.
Good afternoon. Actually, I'm from Pune, and in Pune, you can observe Gliricidia sapium plantation in the Pune University campus as well on many hills like Taljai, Vetar, Tekdi, and all over in Pune. So, what I have observed over the years, there are so many genera growing on this Gliricidia sapium, like Mycena, Merasmiellus, Pleurotus species, and then Favolus, then Panus alpacus is there. So many genera are growing on this Gliricidia sapium, and this Gliricidia is actually introduced. So what might be the reason, or have you observed any such kind of host association in any other genera, or can you please shed some light on this? What might be the reason that this particular plant is actually hosting so many genera?
So, from a cultivator's perspective, when we give a mushroom a substrate, we look at what it likes to eat, right? What the mycelium likes to decompose and hence grow itself more to form mushrooms, which sometimes highly depends on the carbon level of that particular wood, the type amount of lignin, cellulose, hemicellulose, etc. So mushrooms can be host specific. That being said, some mushrooms like Marasmius are very resilient. They will grow on a lot of different wood types. So, what was your question exactly?
Actually, have you observed such kind of host association, specific
Yes.
host association?
Yes.
Because only one this Gliricidia is actually introduced. So, any kind of host association, interestingly, have you observed?
Yes, in nature, like you will see a lot of mushrooms which are very specifically growing on a certain type of trees. For example, in Madiwala in Bangalore, Hari recently saw a lot of particular. Hari is Indian toadstool. I am sure you know about him. Uh, he saw a lot of cherry trees hosting this type of Pleurotus, which we also want to know what it is. Then there are a lot of trees which the Ganoderma will choose to parasitize on also. So it depends on, I think, either the life of stage of the tree, if it is having like a dead decaying bark to be consumed, is my assumption, or then it depends on the type of the carbon composition of the wood, which supports the mycelial growth. Since I'm not very versed with the genera and trees, I will not comment on that because I can be wrong also. But it is true, a lot of saprophytes, if growing on a live tree, will choose the type of tree they're growing on.
I think host specificity is it involves the way taxonomies define a species. Whether the specificity is at this strain level, species level, genus level, or what level. So it's a tricky question, and you will learn a lot in coming years and let us know after some years.
Yes, yes.
Yeah, thank you. Hare Krishna, please.
My guru has a question here.
Hi, Vhyom. It was a very nice presentation. I could join only in like halfway. Yeah, so I have a question. As you are from both cultivation and identification background, so there are certain species of mushroom that exhibit a different morphology when grown or cultivated, and in wild they look entirely different.
Yes.
So, what could be the reasons? Is it because of the conditions in which they are grown, or can we mimic the same conditions to get the wild morphology? So, this is something that I would like to know. So, yeah.
It's a beautiful question, Hari. So the answer to this is, it is very true that I'll say very simple example. If we know about the mushroom Pleurocybella, okay, and the Pleurotus, which is the oyster mushroom. If you have a mushroom fruiting kit, and if you top fruit a mushroom of Pleurotus, it looks very much like a Pleurocybella. Okay, but if you side fruit it, it will come very much like what you see in the wild. That being said, as a cultivator, it is very important that we give the mushroom its right conditions. Those conditions are most of the time mainly good fresh air exchange, good humidity levels, the correct temperatures for it to fruit, and some will require light in their stages of development. Now that being said, when you see a mushroom in wild, some will have very long stipes, some will not have very long stipes. Okay, the shape of the ganodermas can be sort of different. Some, if you cultivate a wild mushroom, they like if you cultivate a ganoderma, it may have a very thick width of its fruit body, but in outside in the wild, you may see very thin, elongated fruit bodies. So mimicking the conditions can be a very intense project, because it can be very hard, because you'll have to control the humidity levels and the CO2 levels, which is calculated as parts per million in the air. So generally, fruiting rooms will keep 800 ppm generally for mushroom fruiting bodies. But if you can alternate that, maybe the fruit body structures will change. So that being said, cultivated mushrooms can be identified, but whatever I shared today on the slides was mostly related to mushrooms that you find in the wild. Okay, this is just I'm sharing. But as Hari asked, is it possible to do? I think it is possible to do, but it can be very tricky.
Thank you. Thank you. Thank you.
Thank you, Hari.
I mean, I just didn't understand the question. Why do you want to mimic the morphology? Right? How does it?
Hello.
No,
Can you hear me?
My question to you, I mean, what is the need for mimicking the morphology in your lab condition, so that it can have better commercial value or something like that?
No, sir. It was just because Hari asked it. There is no reason. You can just go on.
Okay. Any more questions?
Yeah, excuse me, my name is Kaladaran. I was given an opportunity at that time, I could not pick the phone. I am from Kerala, Cochin. I am not a mycologist, but as a layman, I want to ask that, it's an ITK. I learned from my mother that mucus or mucilaginous appearance on the cap. would indicate that it is edible. Is it in, especially in agaricus? Is it so?
No, sir.
Okay. Okay, that was I used to identify because at the onset of southwest monsoon in Kerala, we start getting a lot of mushrooms in open field area. So I used to love pick up mushrooms and for edible purposes. So yeah.
So, sir, with some mushrooms, it can be that they can be allergic to some people and not allergic to some people also. For example,
Okay.
I mentioned about the chanterelle mushroom in this. So, some person I read on the internet, someone loved to eat chanterelle mushrooms, but someday they had chanterelles a bit more and they had like amazing diarrhea problem. Like,
Okay.
they felt it's going to blast out. I hope you're
okay.
So, it can be. It's a very dodgy topic, and just looking at the cap and finding it has mucus like substance, I don't think it's a very accurate way to talk about edibility.
Okay, one more thing. I loved your presentation, and I thank Vhyom as well, Dr. Vhyom as well as MicroAsia team for bringing up, giving an opportunity to learn more about edible fungus in general. And I have a suggestion that why can't you publish a colorful book, monograph for especially identifying edible mushrooms alone. That would be.
So, sir, one thing, I am not doctor. There are many doctors in this.
Okay. But your approach was like a doctoral fellow.
Thank you so much, sir.
I will share a lot of mushrooms from photographs of mushrooms whenever I collect, and I will be visiting Canada. I will try to take from Banff area. I will collect a lot of photographs and send you.
Sure, sir. I will enjoy doing identification.
Thank you. Thank you very much. Once again,
coming back to
once
your
again,
question,
I thank you all.
Thank you, sir. Coming back to your question, if we can make a book on edible mushrooms or not, again, see, if I make a book on edible mushrooms and someone has it and this is my perspective. And why am I so anxious about it? Why edibility gets so anxiety is because if the person by his fault is not doing the correct work in terms of identification and still he ends up eating the wrong mushroom, they will blame the publisher or the writer of the book, right? That being said, I work at Nuvedo, and Nuvedo is a company which works on spreading mushroom knowledge. We make medicinal extracts, we make grow kits, and we have recently Hari, me, myself, Vhyom, Jashid, Prithvi, who are the co-founders, and Srikant, who's the head of marketing at Nuvedo. We all came together and we have made a 15 mushroom book, which you can easily find in Kaban Park and around Bangalore, which has some edible mushrooms mentioned in it. So that being said, that will be out soon. If you wish to buy it, please buy it. And again, if you don't find a journal like that, or if you don't find a guidebook like that, just Google the name and look at research papers that the academic community has been making, which is the actual scientific evidence that you should look forward for. If you ask me personally, because it comes to edibility, which is a very crucial topic, and hence figure it out till there is no strong-minded person to make a book on edibility.
Thank you very much.
Yeah, thank you, sir.
I want to add a couple of points here. There has been one paper published by Samantha as a co-author, and which lists around 2,100 plus edible mushrooms of the world. I think if Mr. Kaladharan is interested in that document, we can share with him. You can just leave your email address in the chat box. We will send the paper to you. Second thing is that, as I understand, out of these 2,100 plus edible mushroom species, only 60 species are commercially exploited. So making a document of 60 edible species of mushroom which are commercially exploited should not be a big deal. Maybe we can have one web page on MicroAsia which can list the species and show the information about it. Actually, thank you so much for those questions. Yeah.
Sir, I would just like to comment this for the sake of humanity, is that there have been tribes who have been eating mushrooms from a very long time. As Kharpran sir from Meghalaya recently mentioned that they had cases of people having vomiting and death also. It is amazing to have answers to edibility but it is still a very risky topic because it again depends on how well you identify the mushroom. So just be careful, whoever is willing to test their guts out and see.
Basically, can you hear me?
Yes, I can, sir.
What I'm trying to say is there are 60 mushroom species or varieties, or varieties, which are proven to be edible and which are commercially used in our day-to-day life, actually. So the list of those can be made available to the interested parties. Maybe on, maybe on myco.asia or myco.asia learning platform. Yeah, thank you for that.
Even I would like to have a copy of that.
No, it will be just a page on our MicroAsia learning platform. No worries. Yeah. Thank you. And Vishital Chaudhary, the last question from Vishital.
Hello, am I audible?
Yes, ma'am.
Hello, am I audible?
Yes.
Okay. Hi, Vhyom. So my question is, how do you identify? Actually, I often got confused with the two species. One is Mycena and the Lactocolibia. How do you differentiate between these two species?
Okay. So one is the stature, overall stature. Okay, for Mycena and Lactocolibia, Mycena are bonnets like helmet shaped. They are called fairy helmets. So helmet shaped. Lactocolibia will not always be in that stature. It can be slightly more convex. Okay.
Okay.
And the thing that I see is the gill underside and the stipe attachment for Mycena is very central, whereas Lactocolibia can have a slightly off from the center of the stipe. Okay, that is second observation that I look for. Third is the gill attachment. This is a tricky one because in Lactocolibia you will see certain, like, it is almost nearly close gills of Lactocolibia and Mycena both, but Lactocolibia certain gills will be very much adnate, whereas Mycena has adnexed gills. And then sometimes if you go closer, you can see cross veins anastomosing in Mycena, which I don't think is present in Lactocolibia. I'm not sure about this one, but I think it's not present. And Lactocolibia can have a white to off-white color. And if you go through all this and then you find, okay, white to off-white color, maybe you can differentiate between a Mycena and a Lactocolibia. That being said, both of them are very similar. So nice question.
Yeah. Okay, thank you. Next time I'll try to notice all these characters that you mentioned now in both of these species. Thank you. Nice to see you in this way online. Hope to see you again. Thank you.
You can also compare both species in your hand and do that. That is the best way to figure out differences, by the way. Keep them together.
One more doubt. This is actually my assumption that because I have not came across the Mycena species mostly, but Lactocolibia I've seen more. So one of my assumption is that Lactocolibia is more brittle than the Mycena, right? Is it right way to identify?
See, brittle is used something which will like break or crumble off very easily, right?
Yeah, crumble off very easily.
I think Mycena are also very much like that. They are very sensitive.
Okay.
It's not a very prominent thing, but let me test this out next time. Thank you for noting down, telling us what you find to be different. And I will
because every time the gills, observing gills in such a minute specimen, because both are minute I mean the smaller in size. So there I got confused with noticing the gill characteristic. So I prefer this specific, character, the brittleness or the crumbliness, to identify or to distinguish between two. I hope this is the right way. So that is what I wanted to ask you. Okay.
You can find your own ways for sure, yeah. But what I shared in the slides is more what is generally used. So, but you can have your own ways.
Yeah. Okay. Yeah. Thank you. Hope to see you soon.
Yes,
Bye. Yeah.
Ladies and gentlemen, I'm sorry that I will not be able to take any more questions. I have already shared Vhyom's email address and link to his LinkedIn profile. So you can just contact him and get your queries clarified. And he is very active on Microasia Fungi ID WhatsApp group. You can catch him and just get your queries answered there. He's a nice man. He will be happy to answer your questions and clarify your doubts. Mr. Vhyom, thank you very much. It has been a wonderful session with you.
Thank you, Mike Asia. Thank you, Pele sir, for this beautiful time and giving me time. And I would like to thank Hari, Jinu Cheta, Arun Kumar sir, and all the great mycologists who have been working in this field to make this information available to me and us, so I can also share it to others. Thank you so much.
And then the collective learning will continue. We will learn from
Yes,
yeah.
we are all mycelium network.
Yeah, thank you. And I would like to thank all the members of in the audience for your great participation, your questions, your enthusiasm, your support to Vhyom, your support to Microasia. And with this, we end up this session. Thank you, everybody. Have a nice Sunday wherever you are. Bye-bye.
Much love.
Bye. Bye.
Thank you, Belle sir, for making this Sunday very special.